Right, grade 12s, in this lesson we're going to be focusing on finding the equation of a tangent to a curve at a given point. Have a look at this. Let's say you've got a parabola. Let's call it f. Okay. What I want to do is I want to pick a point on the curve at some x value. We're going to call that point t, and I'm going to give you the x of point t. So you're given the x of t. Now, what we want to do is we want to find the equation of the tangents to curve f at xt, at that x value. Now the way we do it is we know that the tangent is a line, and we know that the equation of a line is given by y minus y1. In this case we can call the y value the y of point t. There it is there, the y of point t. So it's y minus y1 is the gradient of the tangent, the gradient of that tangent line, into x minus the x value. Now that's the formula for an equation of a line. So what do we need to be able to find the equation of a tangent? We're going to need the x value and the y value and the gradient to be able to do that. And remember that the tangent is connected, it's attached to the curve of f. So the x value here will be applying directly to the curve. And how do we get the y value corresponding to the x value? You work out the f of the x value, f of t. The gradient is determined by working out f prime of xt. Now don't worry about this, we're going to explore an example where we bring all of these concepts into the picture. Okay, so if you've got an x value, you're normally given the x, you work out the corresponding y value by subbing into the original equation, working out the f of the x value, and the gradient of the tangent, you simply differentiate the equation of the parabola and you plug in the x value and you'll get that. So let's pursue an example quickly of this. Have a look. I'm going to ask you to sketch a parabola, and in this example, the first part is I want you to sketch this graph. We're going to revise a little bit of parabolas from grade 11. So fx is equal to negative 2x squared plus 8x, a very sad parabola. And then I want you to find the equation, or find the equation of the tangents, at x is equal to 3. Okay, and then I want you to find the equation of the tangents, at the parabola's turning point, at the turning point of the parabola. Okay, so the first thing we're going to do is we're going to sketch the graph of the parabola, and then we're going to find the equation of the tangent at x equals 3, and then the equation at the turning point. So let's sketch the graph of fx quickly. Here we go. Number A. Well, we know that y is equal to negative 2x squared plus 8x. How do we sketch a parabola? Let's start with the y-intercept. What do? We let x be equal to 0. So what would your y value be? Well, all the x's go to 0, so it cuts at 0, 0. So your y-intercept is 0, 0. Okay, how do we get the x-intercept? Let's revise this. We let the y equal 0. So 0 is equal to negative 2x squared plus 8x. Okay, bring them across so we make our lives a little bit easier. Divide throughout by 2 and have a look at this. Just normal quadratic equations. And we can haul out the x and we get ourselves two good-looking x-intercepts. There we go. So the parabola cuts at 0 and at the x-axis at 4 and 0 as well. Okay, now the turning points, I'm going to use calculus to do it. You can use minus b over 2a or any other method that you like, but I like calculus. This helps us a lot. We get the gradient of the parabola, which is the derivative. Bring down the 2 and subtract 1, multiply with the 2 there, so it's negative 4x to the 1, and the derivative of 8x is 8. What happens at a turning point? The gradient of the tangent is 0 there. So we've got that. 0 equals this, so 4x is equal to 8. Divide both sides by 4, and x is equal to 2. Now all we need is the corresponding y value, so we work out the f of 2, not f prime, but f of 2. F of 2 is the y value at x equals 2. So go back to the original now, and let's plug in our x value of 2. So what does this give us? Negative 8 plus 16, which is 8. So the turning point is at 2 and 8. Okay, let's draw the parabola quickly and let's see what it's going to look like. Let's get some axes here quickly. There we go. And what we're going to do is we're going to plot these points quickly. So we've got the parabola cuts at 0 and at 4. Okay, there it is. 4, 0 is the x-intercepts, and the x-intercept is 0 and 4. X-intercepts, should I say, is 0 and 4, or 0 and 4, and the y-intercept is 0. Then your turning point, now remember, it's 2 and 8, so it goes over there about, not to scale, but 2 and 8, and the parabola's got an axis of symmetry coming down here. Okay, that equation is x equals 2, and the parabola comes up, increases, cuts at 0, goes to its turning point, turns and decreases all the way down. Okay, so there's the graph of f. Okay, great. Turning points, intercepts with the axes. Okay, now the next question is, what is the equation of the tangent at x equals 3? Now, how do we do that? Well, let's draw a little tangent at x equals 3. I'm going to go to a different color. And there we go, at x equals 3. So this is 2 here. That's 4 there. So 3 is about there. So let's go up to the curve. That's x is 3. Put a dot there and draw a tangent, which is our tangent line. Let's call that the point T. And the x of T is, of course, 3. Alright, so we know that the x of T is 3. What we're going to need is the y value corresponding and also the gradient of the tangent. Then we can work out the equation. Now we've got the x of t, so how do we get the corresponding y value? We work out the f of that 3. So we go, if we've got f of x is equal to negative 2x squared plus 8x, so the f of 2, or 3 should I rather say, let's just do that again, f of 3, here we go, is equal to negative 2 times 3 squared plus 8 times 3. So what does that give us? 9 times negative 2 minus 18 plus 24 is 6. So immediately we know that our y value is 6 there. So let's go up to the graph and plonk it in there. So we've got the x of t, the y of point t there. That's the point where the tangent meets the curve. Okay, and all we need now is to get the gradient of the tangent. We have a point on the tangent line. So how do we get the gradient? Well, we simply get the derivative. Now watch this, which was negative 4x plus 8. And what is the gradient of the tangent? The gradient of the curve at 3. So that's negative 4 multiplied by 3 plus 8, which is negative 12 plus 8, which of course is negative 4 there. Okay, so that's the gradient. That is the gradient of the tangent. So we can write it up here. Negative 4 is the gradient. And it makes sense because the line is sloping to the left there. It's decreasing as you go, as you move from left to right. Its gradient is negative. Then how do we get the equation of the tangent? Y minus yt is m, the gradient of the tangent, x minus the x of t. Well, the y of t is going to be, I think it's 6. Let's check it again. There, we've got it there. Y of t, and the gradient is negative 4x minus the x of t, which is 3. So y minus 6 will be negative 4x plus 12 if you multiply out and bring that negative 6 to the other side, and we get negative 4x plus 18. That is the equation of the tangent to the curve. Okay, now the last question, number C, says determine the equation of the tangents. Have a look at this. The equation of the tangent at the turning point. Well, that's easy if you think about it. Let's go up to the curve here. Where is it here? At the turning point, look at that. There's the tangent. The gradient is 0. Okay, but that's the line. That tangent line is y is equal to 8. That's the equation of the tangent there. At the turning point, it's a horizontal line, and its equation is y equals 8. So that's the equation of the tangent at the turning point. So be careful with that. Remember, if you've got your little parabola there, at the turning point, At the turning point, it's a horizontal line. In other words, the gradient at that 2 is equal to 0. But the equation is y equals 8. That is x is equal to 2, y is 8. But it cuts the y-axis at 8. So its equation is y equals 8.